Good afternoon, everyone. Welcome to the Data Visualization in R workshop organized by IPAC Manitoba in collaboration with the Data Science Program of the Government of Manitoba. And my special thanks to the Data Science Program of the Government of Manitoba for continuing their collaboration with us and presenting many useful data science related presentations and workshops to all of our public administrators based in Manitoba. I'm Angela Kulnabagay, one of the program co-chairs for IPAC Manitoba, which is located on ancestral lands of the Anishinaabe, Innuit, Anishinaabe, Dakota, and Dene, and on the homeland of the Métis. We acknowledge the distinct histories of the 7 numbered treaties that apply on this land. We recognize that public administration and public policy have been used as tools of colonialism and the harm this has caused Indigenous peoples. We are committed to promoting public administration in a way that advances reconciliation in a spirit of collaboration with Indigenous people and communities. So once again, thank you, Data Science Program of the Government of Manitoba. Matthew Cook will be facilitating this workshop, leading this workshop today. And Matt is a senior data scientist in Government of Manitoba's Data Science Program based in the Department of Labour, Consumer Protection and Government Services. He is currently finishing his PhD in the Brain and Cognitive Sciences area in the Department of Psychology at the University of Manitoba, where he has taught R workshops to undergraduates, graduates, and faculty members. So without further ado, Matt, over to you, and thank you.
Thank you very much. I'll share my screen here. I'm hoping everyone can see this screen here. So yeah, thank you very much, Angela. So as you all know, we're going to be looking at data visualization in R. And I really think of all the workshops that we could do in R, looking at visualization is probably one of the most important topics we could look at. No matter what you do with data, you're going to be relying on visualization a lot. So certainly if you're someone who interacts with decision makers, the only way they really know your work is through visualizations. They're probably not going to be looking at your code or any of your data cleaning or any of the other sort of groundwork that went into your analyses. Mainly what they're going to be looking at is your visualizations. So they're really important. And even if you're not someone who's sharing results with, say, decision makers or others, if you're working with data at all, you're relying on visualizations a lot just for your own understanding of the data. So we're not going to focus so much today on how to read plots or sort of best design practices, though both of those things sort of invariably will come up. We're really going to focus, as the title of this workshop suggests, on sort of the technical details of using R to make these plots. And if you watched or you were participating or you watched the first workshop we did on sort of an introduction to R, there we only had maybe 15 or so minutes to really talk about data visualization and making plots in R. Whereas today we'll have a solid hour and a half to kind of go through things that we went through in that first workshop in a lot more detail, but also to look at and explore some new things. So we're going to be using ggplot2. And if you were at that first workshop we did, then that'll be a little bit familiar to you. And the benefits of that, of course, is that, like with R, it's 100% free. You're also, in addition to being free, you're not limited with, as you are with maybe some other tools, like some point and click tools, and how you can design these plots and what you're able to actually do. Really, your imagination is sort of your limit. And there's lots and lots of support for using ggplot2 and using this broader set of tidyverse this broader tidyverse framework or set of packages that we're using today. So hopefully everyone can see my screen here. So I have our studio open, and I encourage you to follow along with this. I hope the text is large enough on the screen here. So this is what you should see when you open up our studio for the first time. And I'm kind of hoping everyone, was at that first workshop or has watched it, so they're a little bit comfortable with using R. But I will try to sort of have some reminders throughout for maybe people who are a little bit new. So what we'll do is I'll just go ahead and open up a new R script here just by clicking this little new file icon, clicking R script. And again, I encourage everyone to follow along here. And Daniel and Tyler are in the chat to answer questions if issues come up. So the first thing I'm going to do is just load in the tidyverse set of packages, which contains, or which the ggplot2 package is a part of. So again, you can just highlight that and click run. And it'll take a second here to load, but you should see something that looks like this that says it's attaching packages, and you see some information on what packages are attached, and you see that it attaches the ggplot2 package. My version of R is a little bit older, and you might have some slightly different numbers or different package number, but that's totally okay, or version number, I should say. The other package we'll load up right now is the Gapminder package, which we used in this first workshop. And we'll just use this data from this package called Gapminder to do some of our visualizations. I get a warning message down here that I'm running a little bit of an older version of R, or that this package was built under an older version of R, but that's okay. As long as you don't get an error saying that it can't find the package Gapminder, you should be good. So to get started here, let's just make a plot, and we'll kind of talk about that in detail and see what we can do. So we'll start off with this Gapminder data set. So in this Gapminder package, there's a data set called Gapminder. And if we highlight that and click run, or just have our cursor somewhere on that line and click Control Enter or Command Enter, we will see what that data looks like. So it's good to remind ourselves what this data is. So we got 1,700 rows and 1,704 rows and 6 columns. The columns, we can see a few of them here. You'll probably see more of them. I have my font quite large, so it's easier to see. But you can see that it shows us the additional columns here. I have one extra column, GDP per capita, that's not showing up. But each row represents a country with data collected for a specific year. So we have Afghanistan. This data was collected in 1952. We have the life expectancy, the population, and we can't see it, but also GDP per capita. So let's start by making a really simple plot here. So again, I encourage you to type this all out and follow along, but we'll just type this all out and then we'll maybe talk about this. And we can even so what we have here is we have Gapminder data set. We can take a look at that and remind ourselves what it is. Then we have this pipe. So if you were following along with that first workshop, you already know what that is. But if not, really what we're doing is we're taking this data set and we're piping it, or we're sort of passing it along to the function that follows. So we have this ggplot function, and then we have a bunch of information that sort of tells ggplot what we want on our x variable, what we want on our y variable, and then what type of geometry we want plotted, whether that's bars or points or what have you. So if we highlight and run all this, we will get this plot here. It's a little squished on my screen because I'm trying to make this font larger for you to see, but it should come up a little nicer on your screen. We can always click this zoom here and open up this plot just to take a look at what we have. So you can see that as we sort of wrote out there, we have GDP per capita on the x-axis. It's a little blurry on my screen here while it's sort of re-rendering there. So we have GDP per capita on the x-axis, like we specified, life expectancy here, and then we have a whole bunch of points representing each one of those rows in the data set. So the nice thing is that really for any type of plot we might want to make in R, if we can sort of remember this pattern, we can really make any type of plot we want. And realistically and practically, we can even simplify this a little bit, and then we'll talk about the details of what we're looking at here. So I've just copied and pasted this, but what I'm going to do is just get rid of this mapping part get rid of this x equals and get rid of this y equals to make this a little bit shorter. And you can see that that's a lot more compact than in this code here. And the reason we're able to do that is because R is sort of smart enough to know that this part here corresponds to the mapping, so we don't necessarily have to say that. And it knows that this first variable or first column of our data set refers to the X and the second one to the Y. So most of the time you're just going to write the code like this. So this is really the sort of basic template or framework. Once we can understand this, which we'll do in a second, we'll be able to understand any plot that we might want to make. So again, we have our Gapminder data set. If we had some other data set, we'll use some other data sets as we go. We would use that name instead of this Gapminder data set. And then we're piping that into this ggplot function. And inside of this ggplot function, we have this other function called AES. And all that is, without getting into too much details, is it's really a way to map the columns of our data set to certain things that we want to see in our plot. So here we have the x-axis. So we're just telling R or ggplot that we have a data set, or we have a data set called Gapminder. Inside of it, we have a column that's GDP per capita. And we want that to be our x-axis. No matter what type of plot we want to be, we want that along our x-axis. And we can see, sure enough, R put that on the x-axis. And then we want life expectancy on the y-axis. And if we actually just run this first part of the code here, we can see the way that R interprets this, right? So we have our data set, we passed it to this ggplot function, and it's set up our axes for us with GDP here and life expectancy here. So you see we don't have any bars or points or lines or colors or anything on the plot, but that's essentially what this first part of the code does, is it specifies what data we want to use, and it figures out and sort of maps the X variable and the Y variable to these columns in our data set. So that's not too exciting, of course, right? This doesn't actually show any data yet. But what we can do by adding this plus, and the plus in ggplot's really looking at adding something to the plot. So you can think of like a printing metaphor where you maybe print something and then you add things printed on top of it. So very similar to this idea of piping, but it's just adding on to the plot. And here we have geom_point, and as the name suggests, it's going to add some points. So when we run this whole thing, we have points, and of course they're not just any old circles, but what they are is they represent the coordinates or the locations of these two variables. So if we looked at Gapminder and we look at, I'll have to just move this over a little bit here so we can see it. Oh, it's still not wide enough to see. So does that do it? Yeah. So if we look here, right, these points that it's plotting are this life expectancy point and GDP per capita. So it's putting a point at 779 on the x-axis and 28.8 on the y-axis. And it's important when you're sort of building these visualizations to sort of understand and appreciate what exactly is being plotted. Too often I see people sort of just take some data and try to plot it without a clear understanding of what they're trying to actually visualize. So it's important to realize when we're looking at this, that each one of these points represents a row in our data set, and the x-axis represents that GDP, and the y-axis represents the life expectancy. So that's how we make this sort of very basic plot. I'm just going to copy this and we'll sort of riff on this one idea we have here and see how we can add some different things to it. So we can see that one of the problems we have with this plot, of course, is that even if I open this up here, because there's so much data, there's 1,700 rows in this data frame here, we have what's called overplotting, right? We don't actually see points here. All we see is just a big blob of black, and it's hard to differentiate the different points. So one of the things we might want to do is change that so we can change the transparency of these points to get a clear visualization. And we'll see what that looks like here. So in graphics and plotting, alpha usually refers to sort of the transparency of things. So what we're doing here is changing the transparency or the alpha of the points. So let's just set it to, say, 0.25. And this alpha parameter or range goes from 0 which would make the points completely transparent, so invisible, all the way up to 1, which is the default where they have maximum transparency. So if we change this here, we can see that the points become more transparent, and it's still not quite good enough for what we want to do. But we can see that rather than just having a pure black blob here, we can actually see the areas where there's a little bit more overlap. So each point here is a little bit more transparent, and we can actually see the areas where there's a lot more data. And that's really useful for when you have a lot of data, and there's so much data, we might actually want to reduce it a little bit more so that we can get a clearer idea of where those areas with a lot of data are. And we'll sort of see how we can use this again a little later on. Another thing that we might want to do is when we looked at the data, we saw that each point, each country, of course, corresponded to a specific continent. So if we look back at the data here, each one of these points corresponded to a specific continent. What we might want to do is color code these points so that we can see which ones corresponded to which continent. And of course, it's reasonable why we might want to know that. That just tells us a little bit about the pattern or the structure in the data. We might want to see, well, maybe all these places here with low life expectancy down here, maybe those all correspond to a particular continent. So to do that, we can do that within this aesthetic here. So I'll just copy this so that we can remember how we've changed things. So we had our X variable and our Y variable. What we can do here is say that we want the color to be equal to continent, because that's the variable in our data set that has the continent there. And if we run this, we'll see that we get exactly what we're looking for there. So move this over. So we see that now each one of these colors, these points aren't just black, but they're actually colored according to the 5 different continents here. And you see that R is really nice, right? ggplot, it's made us this legend already. We didn't have to worry about that. It's sort of assigned colors that are different enough from each other so we can visually tell the difference. I'll maybe just change this alpha a little bit just so the colors come up a little bit darker, so it's easier to see, right? But R and ggplot have done all these nice things for us, and we don't have to fiddle around with legends or figuring out what colors belong to where. We can certainly change all of that, and we'll talk about that in a little bit. But we can see that R does a lot of nice things for us. Another thing we could do too is rather than color coding this, maybe what we want to do is color or change the points by shape. So this is another aesthetic or option that we can change. We can change shape to be continent. So now rather than having shapes or colors corresponding to each of these continents, we have the shapes. And again, you can see that R has just picked these shapes for us. And of course, there's nothing stopping us from doing multiple aesthetics. So we could include both color and shape. So let's do that here. And I'm just going to go ahead and put this on to the next row here so it's all visible on the screen for us. Right, so now we have, again, we have our x-axis or y-axis, and then we have shape by continent and color by continent. And if we take a look at that here, sure enough, now our each point has both a color and a shape, right? Which is maybe a little bit redundant, but it sort of helps with understanding the data and sort of seeing the differences. And maybe something like this would be important if you were going to convert a plot, and it might be potentially in black and white or something like that. So there's still a way for people looking at the plot in black and white to see the difference between the points, or for, say, people who are visually impaired or colorblind, they might not be able to differentiate, say, the red from the green. So having both color and shape mapped to that aesthetic makes it accessible for people. So these are some of the different things that we can do. The sort of last aesthetic we can look at is size. So I'll just get rid of this here. And size typically will be for another variable that's numeric rather than categorical. So what we can do is use population. So let's take a look here. So now we have size is the population of each one of these points. So you can see, for example, this point is quite large, indicating that it came from a population that's a little bit on the larger side. Maybe what I'll do is turn this aesthetic or this alpha down a little bit so it's a little bit more transparent for us. And we can see some of those points are really big. So some of these areas here that have very low GDP per capita, we can see that they have very high populations. And again, looking at this plot, this gives us a lot of information. And if we were only looking at this data for our sort of own understanding to make sense of the data, this might be good enough for us to understand it. But if we were sharing this with someone, there's some things we might want to change, right? And right off the bat, these labels here, aren't necessarily the nicest, right? It'd be nice to put in a little bit more readable labels. If we look at this axis here, it'd be nice to sort of break this up with, say, a comma, so 90, comma, and then 000, to sort of make it visually more obvious that it's 90,000, so that you don't have to squint and count the zeros here. And then, of course, this legend here is kind of ugly. It has this this sort of scientific notation here, where it's showing that to understand what this number is, we have to move the decimal place over to the right 8 places, right? Again, it doesn't make it very intuitive what these numbers are for people who aren't used to looking at that. So R has done its best to do a good job to help us with this plot, but it's obvious there's some things that we're going to need to adjust. And we'll talk about how to adjust those things in a little bit. Before we do that, though, let's look at some other types of plots that we can make. So for example here, let's look at another data set here for this called economics. And this is preloaded into R, and we can take a look at it just by running this to see what we're dealing with here. And we can see that we have 500 rows and 6 columns. And we have a date column, and we have population and unemployment. So let's say, we were economists or something like that, and what we were wanting to look at was unemployment over time, right? So looking at what we've thought about before, let's see how we can make that plot. So we know we want to use this economics data. We're going to pipe that into the ggplot function, because every ggplot starts that way. And we're going to set our aesthetics. Or we're going to map these different variables to what we want to see in the x-axis or the y-axis. And you actually see here, R is helpful and brings up this little tooltip, this little pop-up window, reminding us that we need to give it an x and a y. And we can write out the x and the y. So on the x-axis, we'll have the date. On the y-axis, we'll have, say, unemployment, which is, and you see you can autocomplete here. Just click that. And again, we don't need to actually have this x or y here. I'll just go ahead and take that out to make it a little easier to see what's going on here. And let's just run this and see what we get. So if we run that, we see that we have sort of as advertised in our code. Let's just take a second to pop up here. We have on the x-axis, we have date, and we can see it ranges from about 1970s up to the 2010s there. And then we have unemployment here. And you can see that R has done everything to sort of set this plot up for us, but now we need to tell R what we actually want to plot. So we could try plotting those points like we did before, right? And again, it's really important to be clear on what we're plotting here. So for this first row, what we're going to be plotting is for the date of 1967 for the 7th month, the first day, which is, what would that be, July? Right, July 1st. So on July 1st, we're going to be plotting the number 2944, right? So back in the 1967s there, 2944. So that's going to be way down here somewhere, right? And R is just going to go through each one of these rows and plot a point. So if we run this here, we can see, sure enough, that's what we get, right? We get 1 point for each one of those rows. Now, of course, this is a little bit of a strange way to plot things with these points here. What we might want is, rather than a point, we just want a smooth line showing this trend, right? Because these points are so close anyways, it's probably a little bit more helpful to view this as just a straight line. So the nice thing is, And unlike some other plotting tools, either in R or in Python or other tools that you might use, we can really keep everything that we've written the exact same. The only thing we need to change is this geom_point. So rather than our geometry being points, we want it to just be a line. And everything else stays the same, which is really beneficial for trying things out really quick. It saves you a lot of typing. Now you see we have here what we wanted, right? We have time on the x-axis, we have unemployment here, and we can see how unemployment has changed over time. I'm not sure where this data comes from exactly, if it's from the United States or from somewhere else, but it doesn't really matter for our purposes. Now, just like with how we had multiple aesthetics here, so we had shape and color, we could add two things for the same variable. We can really do the same thing here if we want with the geometry we put on, or the lines and points. So what we could do is we could add a geom point too, right? So now we're going to have the lines, and it knows where to draw the lines because we've specified our x and our y here. And just like with this geom line, the geom point also is going to know where to put those points. So if we run this here, we see that we have both points and the lines connecting them. And this can be a really nice way to visualize the data because it makes it clear that the points are where we actually had observed data, and the lines connecting the points are sort of that interpolated data, right? We didn't actually have data and the dates between those two points, but it's reasonable to connect them given that they're probably only a day or two apart, right? So, and the same idea applies. We could add other geometry in there if we wanted to. Let's just see here. Yeah, so we can go ahead and do that. And that's something that you'll do all the time is use, say, points and lines. So let's kind of keep going with this theme of looking at the different types of plots we can make and see how we really only have to change this part of the code to get a completely different type of plot. So let's go and maybe we'll go back to the Gapminder data set here. Let's say we wanted to make, say, a bar plot, right? So let's say we look at the data here. Let's say, we were just analyzing this data and we know we have 1,704 rows. And what we want to do is get an idea of how often each continent appears. So we can see that Asia appears quite often. That's the first 10 rows. But we want to know, well, how many continents are in this data set? Is it only Asia? That's all we can see so far. Or are there other continents? And how often do each occur? So to do that, maybe what we'll do here is we'll count the continent, right? So this isn't specific to ggplot. This is just a function within the tidyverse that allows us to count different columns. So if we run that, we can see that we get a count of the column or of the continents, right? So we have these 5 different continents: Africa, Americas, Asia, Europe, and Oceania. And we have a count of how often each of them occur in the data set. And if we summed up this column here, we would have the number of rows in our data set. So now the nice thing is really what we've done is we've made ourselves a new data set for the purposes of plotting it, right? So now we have this new little data set here. And what we can do is we can plot it just like we did with the original Gapminder data set. So we can pipe this little data set now into ggplot, and everything here is going to be the exact same. So let's say on the x-axis, we want a continent. And you notice once you start to type Conte, you bring up this toolbar here that shows you everything you have in your environment in R or loaded in R that starts with that. So we can just go down here and click continent to auto-complete that for us. So continent's what we're going to have on our x-axis. And on our y-axis, we're going to have n, which is the count of the number of times each of these continents appear. So if we run that, take a look here, we'll see that R has set that up for us, right? So on the x-axis, we have each of our 5 continents, and on the y-axis, we have n, right? And it goes up to 600. R has sort of figured that out for us. So now what we want to do is add some geometric objects, right? We want to add something so we can visualize the data. Now, of course, we could put points, right? There's nothing stopping us from putting a point here. And what it's going to do is, say, for Africa, it's going to put a point at 624. The Americas, it's going to put it at 300. Well, let's take a look at that here. So this is a totally reasonable plot for us to have, right? Shows that the number of times Africa appears is 600, the Americas appear about 300, Asia 400, and so on, right? That's a totally reasonable way to display the data. But more commonly, we probably want to use, rather than points, we want to use columns, right? So if we use Geocall, we can add columns rather than the points. It's really showing the same data, but it's just changing the geometry we have there. So if we look at this, we see that we have the same plot as before, but it's just columns rather than points, right? Now, a reasonable question you could have is, well, how did I know that this was call and not column or something like that, or something completely different? The nice thing is that, again, with this R trying to be helpful theme that we've been on, if you type in geom underscore and push tab, or it might just come up automatically, you can see all the column, or all the geometry types that you can use. So there are dot plots and error bars, there are hex plots and histograms, maps and paths and polygons, rugs, right? All these different things. And we won't have time to go through all of these today. We'll go through a handful. But when you're trying to make a new plot, even just Googling what some of these things are might give you a hint on what type of plot you want to make if you're trying to do something new that you haven't done before in ggplot. So we'll just stick with that column plot. And just like before, we can start to change some of these things. So let's just say, just for fun, we wanted to add a bit of color here, and we don't want just these boring gray bars. Well, we can use everything we talked about before and add some color. So if we say color equals continent, we can change the color. Now, this isn't actually going to do what we want here. We'll see this quickly. We'll see that rather than actually change the whole bar, all it's done is sort of change the stroke or the outline of each of these. So if we want to change when you're working with bars, if you want to change you're working with columns, if you want to change the entire color, what we'll do is we'll change, instead of color, to fill. And it's something you just have to kind of remind yourself. And most of the time I forget, and I have to go back and change that to fill. But we see that that does exactly what we want here. And now each one of these bars is colored, which is maybe kind of nice. And we've got this legend added. Now this legend, we could look and say, well, this is kind of redundant given that we have these labels under here. And in a little bit, we'll talk about how to remove the legend or move it to different places when maybe we want it to be somewhere else, or even if in this case, we don't need it. So that's looking at an instance where you're making a bar plot or a column plot where you only have one variable, right? So all we plotted was the continent here. But sometimes what we want to look at is not just one category, but we want to look at combinations of categories. And let's take a look at a different data set here. So there's a data set built into R called GSS_cat. And you can see before you type the whole thing, it tells you what that is. It tells you it's a sample of categorical variables from the General Social Survey. I don't know where this data, what country this comes from exactly, but I want to use it just to emphasize this point. Another thing you might wonder is, well, how did I know that this was a data set in R? How could I have ever possibly known that? Just like with this, economics data set, how did I know that that was in R? One of the things you can do that's really nice is type in data, this function data. And if you run that, you'll get this little tab opened up at the top, and it'll show you all the data sets that are loaded into R that either you've loaded or that are parts of packages that that are installed in R currently. So you can see there's this pack, or this data set called air passengers, and there's several dozen here packages, several different packages with different data sets in there. And they're good to play around with, and everyone kind of has their favorite data sets for practicing with. And it's a good thing to practice making plots with data sets that are small and easy to wrap your head around when you're kind of learning this, rather than say loading in a new data set that you might not be quite sure of its structure. So let's take a look here at this survey data. So we can see here that there's quite a big data set, right? 21,000 plus rows and 9 columns. And each one of these rows here refers to a person. So this data here was collected in 2000. It's cut off here, but you'll see it on your screen when your font's not so big. So this person here, it has their marital status. They were never married. They were 26. They were white. Their income was between a particular range. It has the political affiliation, the religion, and so on and so forth. So let's say we were interested in making a bar plot of people's marital status. Let's say this was some survey data that we were tasked to analyze. Let's say we want to understand, what different marital statuses people put in, as well as how often each of them occurred. Well, really, we can use this template here, and maybe what we'll do is just copy this to really see the similarities. So I've just copied this. So Gapminder, nope, we don't want to use that data set anymore. We're wanting to use this different data set. We don't want to count continent because that doesn't exist in this data set. We want to count marital status, so we can do that. And let's just run this here and see what we're dealing with. So we get a count here and we see that 17 people answered no answer, 5,416 answered never married, and so on and so forth. And then we can pipe this little data set that we just made into the ggplot. And we don't have to change too much here. The only thing we have to change is continent. That's no longer in the data set. We want it to be this marital status here. And stays the same. That's perfect. And maybe we'll just get rid of this fill. Right? Geocall, that doesn't need to change. Run this. And now we have a plot for this new data set here. And we can see, just like we saw before, most people in this data set were married, about 10,000 of them, less, about 5,000 were never married, and so on and so forth, right? So this is really useful to be able to see this. But what if we not only wanted to look at just how often people were married, but we wanted to look at the combinations of people who were married and, say, their religion, right? So we wanted to see, within a particular religion, how many people are married, how many people are divorced, how many people were never married, and so on and so forth, right? Well, to do that, I'll just copy this here. To do that, just to see the data itself and not plot it, to do that, we can say we want to count marital status here and religion. I'll just copy that there. And if we run this, we get a little data set that gives us exactly what we want, right? So we have marital status and religion and a count of how often, how many of those people answered that way. So people who answered no answer to marital status and no answer to religion, right? They're just refusing to answer. Only 4 people did that. No answer for marital status, and of people who were Christian, there was 1. And let's scroll down to get something more interesting, right? People who answered, no answer, and they were never married, there was 22 of those, right? And we can see that this is, more data than we can reasonably make sense of. There's 78 different rows here, all these combinations of marital status and religion. So what we want to do is plot that. Now we have 2 different columns, though, 2 different sort of categories we want to plot. But the nice thing is we really don't have to change too much to visualize this. So again, by now you can kind of anticipate what I'm going to type, ggplot. And the aesthetics, we need our X and our Y. So on the X-axis, let's take religion. We want religion on the X-axis. Oops, so that's just religion. On the Y-axis, we're going to have N, just like we had before, which is the count of how many belong to that particular group. And then what we're going to do is say we want fill to be marital status. Oops. And let's add our column in there, Geocall. Again, right, we have our data set. We've transformed it a little bit so that we get this count data. So now it's in the shape we need it to be. We specified our X-axis, our Y-axis, and then we're saying we want to color, or we want to fill these bars according to marital status. So just to get a sense of what to anticipate here, right? For all these people who are married, well, actually, it's going to be a little different. We'll just take a look at it because we switched around our X and our Y there. So let's take a look here. So on the X-axis, we have, and again, this is a little squished. We could, well, here, this is actually a good opportunity because we have so many categories. they're all kind of squished in there. We could do some things like put the text vertically. We could, maybe if we have time, we'll look at that. But a thing I like to do when we have so many categories is change the X and the Y axis. So if we change this, so we have, right, so now our count is going to be on the X axis, the religion is going to be on the Y axis, and everything else stayed the same. Now, when we flip that around, it's a little easier to read because these are horizontal. So that's a nice trick when you're making a plot with a lot of categories, is just to put the categories on the y-axis there, and then the counts on the x-axis. So you can see what we have here, right? For the people who say answered Protestant, we can see that, you know, I don't know, 50% of them or so are married, right? I don't know what, 10%, 5%, it's hard to say, are widowed and so forth, right? So this lets us visualize 3 different variables at once now, right? We have marital status, religion, and then how many of those belong to each category. So this is really helpful, and this is a plot you'll probably make all the time if you work with categorical data or data with that's, you know, categories like this, but it's sometimes not the greatest, right? So if we wanted to compare the lengths of, say, this, you know, this sort of light blue bar here to this greenish brown one, we have to sort of visually step back and look to say which one there is more of. So a sort of more common plot is, rather than have these bars stacked, to have them side by side. So it's easy to see not only these differences between the groups, but the differences within them. And the nice thing is, you know, as you might imagine, we don't have to change this plot very much to make this new plot. We only have to change one option in this Geocall function here. So if you put your cursor in this function, or any function really, and press tab, what you'll get is this helpful list of options for this function. And you see that one of them is position, and it says that a position adjustment, either string, blah, blah, blah. Okay, not particularly helpful. But if we have position equals dodge, and there's no way that you could have known this ahead of time, this is just kind of something you learn as you work with ggplot, read books about it and attend workshops like this. But if we change the position to dodge and we run this, we'll see that we get the same data displayed, but in just a slightly different way, right? So rather than these colored bars being stacked, now they're side by side. So we can actually look, you know, for this category none, for instance, we can see that, you know, there's about equal number of people who are married and never married, but there's a little more people who said never married. And, you know, it lets us actually visualize not only between groups, like I said there, but within groups too. So depending on how you're looking at the data and what you want to know, these are sort of 2 different options available to you. And another option we can change too, you know, let's say we want to look at this plot and we want to, let's maybe go back to the way this was. And if we change this to stacked, we will get the first, that should be stack actually, I think. We change this to stack, we'll get the original plot we had, and that position equals stack. The default is just to do it that way. But, you know, let's say we wanted to compare the Catholic group to the Protestant group, right? It's maybe hard to look at this plot and say, well, you know, I don't know, married people look like it accounts for about 50% of the Catholics in this survey, and, you know, maybe a little less than 50% for the Protestants. It's really hard to say, right? So what would be nice is if there was a way that we could expand these bars so that they were all the same lengths, so that they all sort of equaled 100%. And then we could see each of these groups by a percent. And there's different ways we could do that, but one really simple way is if we just change this from stack to fill. What we're going to get is a bar plot, very similar to that stacked bar plot. But now, rather than having each one of these lengths being the number of people that was in each one of these religions here, what we see is that all of them just go up to 1, so a proportion. And now each one of these colored bars shows us the percent of people within those groups. So now, you know, if we want to compare 2 of these groups here, it's very easy at a glance to see within each of these groups what percent of people fell into each of these groups. And we can see that the x-axis here, rather than a count, is the proportion from 0 to 1. And And we might want to change that as a percent, and we'll talk about how to do that very shortly. So we've looked at how to make, scatter plots with these point plots with geome point. We've talked about how to make line plots, geome line, connect those geomes, column plot or a bar plot here. We'll quickly run through a couple other plots quickly, and then we'll look at some other things that are really useful to do with ggplot. So we'll just go through some of these examples quickly. Let's go back to the Gapminder data set here. And we'll use our classic ggplot static. On the x-axis, maybe what we'll have is life expectancy. And what we'll do here is we'll make a histogram. So related to the bar plot, but really what it's going to do is take that life expectancy and chop it up into little buckets, and then show us how many data points fell into each one of those buckets, right? So let's take a look at this here. Geome histogram, right? And you'll notice this is the exact same pattern as we had before. We have our data, we're piping it or passing it to this ggplot function. We're only giving it one variable in our data set, which is the x-axis in this case, life expectancy. And then we're saying we want a histogram. So if we run that, we see that we get a histogram. And what this is doing is it's showing the life expectancy here on the x-axis, and it's binning each one of those life expectancies into little blocks. So here maybe it goes from 40 to 41, and it's showing you there's about 60 or 70 people, 60 or 70 rows in the data set that had a life expectancy between those ranges. And you'll notice that we got a warning message from R here saying that it made 30 bins for us, right? So it took our life expectancy variable and it chopped it up into 30 different discrete bins, and that's what it's plotting here. But it's warning us that if we want to change that, we can do that by picking a different number of bins, right? So just like we did before with this position equals fill, we push tab here, we can see these options available to us. And one of them is bins. So let's say we want to have not 30 bins, but 100. This will show us the data in a little bit more granular detail, right? So you can see there's a little kind of a drop here. If we wanted to change that to less bins, so things are a little bit coarser. So now we're looking at a much wider range, right? Maybe we're looking at, this shows us the height of this, let's say it's 160, shows us that in our data set, there are 160 rows, say between 35 and 55 life expectancy, right? And of course, if we only had one bin, we're gonna get just one big block, and the height of that shows us the number of rows in our data set. So that's not particularly helpful. Another option we can change there is the bin width. And what that's telling you is, as the name suggests, the width of the bin. So if we have that as 1, R is going to break up or split up life expectancy by 1 year. So that can tell us here, if we look at 80, that tells us that the number of rows in the data set, or the number of countries in the data set that had a life expectancy of 80 was whatever the height of that bar is, 13 or 14, something like that. So depending on what you're doing, you might want to change that, right? If you were doing something, say with age, and you wanted to look at the distribution of ages within the people of your data set, maybe you could have a bin width of 5, so that you see blocks of 5 years, right? People who were 20 to 25, people who were 26 to 30, people who were 31 to 35, and so on. So that's an option you can play with, but you don't have to, and if you leave that blank, R will just do that for you. So another plot we can take a look at here, and we're just going to kind of run through some of the different common plots you might want to make. We'll keep everything the same here as we did with this plot before. So we have our Gapminder data set. We're going to pipe that into this ggplot function. We're specifying life expectancy as what we want on the x-axis there. But instead of a histogram, we'll make a density plot. And if this isn't something you're familiar with, that's okay. But it's essentially like a histogram. It's just sort of a smoothed version. It shows a line showing the height of these different ranges of life expectancy. So you can see there's not many life expectancies in this Gapminder data set that are low. There's not too many where it's really, really high, right? Over 80. Most of them are, somewhere around 70, and there's another little bump, say, around 45. And really what you can kind of imagine this, I'll just open this up so we can see. It's, if I click this back button here, we can have a history of the plots that we made. So this is the histogram we made here, but you can almost think of this density plot as like draping a blanket over this stack here. And that blanket is going to kind of be smooth. It's not going to follow every little bump. And that's kind of what you get when you look at a density plot there. So it's just another way of understanding a distribution, in this case, the life expectancy. Now, one quick thing I'll show you, because this is something that we use quite a bit. Often you want to understand the distribution of, say, life expectancy, but not overall, but say within continent. What we can do is use that same option we did before, that's fill, and choose continent. And when we do that, what we get is, rather than one density plot, we get 5 in this case. And each one of them is color-coded according to its continent. If I open this up here, you'll see that this lets us see, okay, Africa in this data set, has a lower life expectancy than somewhere like Oceania or Europe. Now, the problem is because these are so opaque, we can't really see what's going on behind, right? For example, the Americas was plotted first, and these other ones were plotted over it, and all we kind of see is this little triangle here. But we already know how to fix that. If we use this alpha parameter, so I don't know if it shows up in here. We use this alpha parameter and change it again, and it goes from 0 to 1, 1 being the default, which is completely opaque. Well, let's say we change that to 0.5. Now we can see that we get a little bit of transparency in the way that those density plots are displayed, and we can see through them. So we can actually see the shape of this America's distribution, for example. And sometimes it just takes a little bit of playing around with to get it just the way you like it. But we can see that this allows us to look at these different distributions. And if you attended our Thinking with Data workshop, we kind of talked a lot about looking at these different distributions for different categories like this, and what we can learn from that. So that's something that you'll probably do all the time when you're working with data like this. 2 other quick plots or types of plots that are very common we'll look at, and then we'll start to look at some other things that are very common that you're going to want to do. So we'll just stick with this Gapminder data set, ggplot, this aesthetic, and we will have, say, life expectancy on the x-axis and, say, continent on the y-axis. And so this is all familiar stuff so far. And rather than points or lines or histograms or density plots, what we'll do is look at a plot called a box plot. And some of you may be familiar with this, and if not, that's totally okay. It's just another way of understanding a distribution. So what we get here is, as we expected, we have a continent on the y-axis here, life expectancy on the x-axis. And then these boxes show a crude understanding of the distribution. So just really briefly, this middle line of each of the box shows the median. You think of it as sort of the average life expectancy. So for Africa, we can see that that average life expectancy across all those countries and the dates that were collected is, a little less than 50. And then this shows the 25th and 75th percentile, which is just about 25th of the way up the data and 75% of the way up the data if you ordered the data points from smallest to largest. And then these points here sort of show some outliers. We won't go into too much detail about how to read these, but suffice it to say, this is just another way of looking at distributions. So this is a very common plot that you'll see in a lot of research articles or presentations and that sort of thing. And related to a box plot is a really cool plot called the Violin Plot. And we can keep everything the same here, but just change this to violin. And again, this is just another way of looking at distributions. So the width of each one of these gives some sense of how many rows in the data set had life expectancies around there. So if we look at something like Africa, we can see that there's not many places where the life expectancy was low or very high, but most of them, given that the width here is quite wide, was around 50 or so. If we take a look at Europe, most of the life expectancies are somewhere around 70, some up as high as over 80, and not many of those countries or times data was recorded are very, very low. And you can see these differences between these different continents here, so to get a sense of how life expectancy changes between continents. So those are some of the main types of plots you'd reasonably use in your day-to-day work. And it's really helpful for looking at the data and understanding it. And again, whether that's you just trying to understand data that you're not necessarily going to share with anyone else for your own benefit, or whether that's sharing that with decision makers or that kind of thing. Being able to look at the data, it's a lot more clear to spot the trends and patterns and relationships than if you just looked at a summary table with a whole bunch of numbers. So another thing that you might want to do is to add some annotations or text to the plot. And this is especially true when we look at, when we have something like a scatter plot. So let's stick with the Gapminder data set for a bit. So let's say we go back to this scatter plot we made here where we have, say, GDP per capita on the x-axis, life expectancy on the y-axis. And let's just make a simple scatter plot. Right. What we want to know, we might look at some of these outlying points here and want to know, well, what countries are these, right? And we could probably look in the data and try to figure it out, right? They're countries with very high GDP per capita. We could probably figure that out. But what might be nice is to label these points here so we can know what countries they are. And one thing we're going to do too, just so we don't have so many points, so we don't have 1,700 points, I'm going to add a line here that will just filter this data a bit. And we'll just say filter equals year, say 2007, I believe is the last year. Right. So now all we've done here is we've taken our Gapminder data set, we've piped it to this filter function, and we said only give us the rows in the data set where the year is equal to 2007. And we see when we do that, we have the same data set we had before, we just have a lot less rows. Each country now, Afghanistan, Albania, Algeria, and so on, only have one row now, rather than a whole bunch of rows for all the years the data was collected. And I'm just doing this so that we have less points here to look at. But let's say that we want to know what some of these points are. We could look at the data and sort of go into Photoshop or Paint and label them ourselves, but of course that would be quite time consuming and tedious. So the nice thing is we can really just add one more line of code and label all of these points. So what we will do is we will add a different type of geom, not a point or a line, but what we're going to add is text. And if we run this, we'll actually see we don't get anything. And in fact, we get an error. It's saying that it's missing an aesthetic called label. So that kind of gives us a clue. If you're not really familiar with R, that's probably not going to be super helpful. But what we need to do to get what we want is, in addition to having our x-axis here and our y, put another comma, and what we want is our label. So label equals, and what we're going to do is put country. And the reason to put country is because we want each one of these points to be labeled by its corresponding country, right? So in addition to having a point where the life expectancy and the GDP is, we want each one of those points labeled with Afghanistan or Canada or United States and so forth. So if we run this here, we'll see that we get this. And this is perfect, right? We can see that each one of these points at a glance, we can see exactly what country these correspond to, right? So we can see that, these ones here that were kind of outliers, seem to be African countries, for this case here. So it's helpful, but we can see that, this has sort of caused a new problem for us in that there's so much overplotting that you can't even read what these labels are and you can't even see the points anymore, right? The nice thing is that there's this one option within geom text, and this is probably like my favorite option within R because it's such a smooth and slick way to solve the problem. There's this option in here that's check overlap. And if you set that to true and rerun this, what R will do is, as the name kind of suggests, is it's going to check to see if there's any overlap between these points, or sorry, between these labels on the points here. And if there is, then it just doesn't put that label. So you'll see that not every point has a label anymore, like these points here don't have labels. But in a place where you have these outliers, it's still easy to look at what those labels are or what those countries are. But in places where there's lots and lots of points, it doesn't overplot that and make it impossible to see. So that's a really nice option to have and to remember when you're doing this type of work, because it makes it easy to see what that data corresponds to without just making a total mess of your plot. So you'll notice here we did a little bit of processing on the data, right? And I've been trying to avoid doing that, really just focusing on the plotting aspect. We're going to have another workshop soon that looks into data manipulation, doing things like filtering and transforming data. But for the most part, I've kind of tried to avoid doing any filtering or cleaning of the data sort of in between the raw data and the plotting, because this is a workshop on plotting. But one thing I want to show you that's really, really useful, that's sort of a cleaning step or a processing step that you use all the time for making plots, is reordering categories. So let's go with our Gapminder data set here. Let's make our column plot. So let's say we want, so let's do a count here of continent, and type that into our ggplot. On the x-axis, we'll have n for our count, y for the continent, and Geocall. So this is the plot we made before. And this is great, right? This shows us our plot. But what's not so great, of course, is that these aren't ordered in any way, right? Like the biggest country is Africa. To find the smallest one, it's Oceania. To find the third biggest, you got to kind of hunt and mentally rearrange these to make sense of which is the largest and which is the biggest. And it's not so bad with only 5 groups, but when you have a dozen groups, it's kind of harder to see. And in fact, let's switch this around and use that survey data. This will probably be a better example. So here, let's count religion like we did before. So we actually made this plot here before, right? Where we're taking that survey data, we're going to count religious affiliation with this. We have 15 different categories. Then we're going to plot how often each occurs, right? We made this plot before, right? So this, lets us see, okay, Protestant is the most, what's the least? Maybe don't know, right? It's really hard to see. So what we want to do is rearrange these so that we have the largest at the top and then getting smaller and smaller all the way down. And the nice thing is this is nice and easy to do within R. And again, this isn't plotting per se, but it's something you have to do with plotting so often that I wanted to show it. So we're going to use this mutate function. And what we're going to do is we're going to mutate the religion variable, and we're going to use this function called FTC reorder. And that's just for factor reorder or categorical variable category reorder. And we're going to reorder. So if we push tab here, you see the first thing it asks for is factor. So this is just the thing we want to reorder, which is religion. And then the next thing we do is say, well, what do we want to reorder it by? And we want to reorder that by the count we had, right? So we want the largest counts and then going down to the smallest count. And best way to look at this is just to see it. So now when we look at our plot, now it's ordered from the largest down to the smallest, which is really helpful. So that's all that line of code there does, is sort of internally, it just rearranges the ordering of this religion variable so that it's ordered from largest to smallest. And we're reordering that by our counts there. And again, this is something that you'll do all the time. Again, whether it's to present this data to a decision maker or your boss or something like that, or it's just for your own understanding. It's nice to be able to see at a glance, well, what are the top 3, largest religions in the survey, and what are the top 3 smallest, options people selected in the survey at a quick glance. So another thing that's really important is looking at, so let's stick with the Gapminder data set and go back to this plot that we've looked at a number of times now, looking at the relationship between GDP per capita and life expectancy. And let's say we have we have this classic scatter plot we've seen a whole bunch of times, right? So if we look at the relationship between these two things, we see that, well, when GDP is very small, it doesn't seem to have too close of a relationship to life expectancy, right? There's a big range of life expectancies when GDP per capita is very small. But as that starts to increase, there starts to be this relationship we can see where as GDP increases, life expectancy also increases. But then it seems to drop down kind of here. So, we can visually see that. But if we want to add a line that sort of shows that trend, we can do so with this other geome called, and we might think it's called line because we want to, have a line that shows the trend through the data. But we'll see if we include this, it actually, doesn't really give us what we want. It just connects all these points. So that's not what we want. What we want is something called a geome smooth because it provides us a nice smooth trend line. And if we look at that, we'll see that we get exactly what we want, right? We have our scatter plot and we have this trend line showing how the relationship between GDP per capita changes over time. And you can see it's quite steep here and then it sort of flattens off there, right? This is a little bit different than I thought just by visual inspection. There's actually, because there's so many plots or points, it's hard to see, but we can see that trend, right? And again, this is really helpful for just understanding the trends of data. Two options that we have available to us is the method. We have several options available, but two common ones is the method. And we can see that this says the type of line we're going to get. And one very common type you're going to want is LM, and that's short for a linear model. And if you've used regression at all, this method LM here equates to the line of best fit or the regression line. And you can see, straight line probably isn't appropriate for this data here, but for data where it is appropriate, this is how you do it. You use that method equals LM. And this gray band here just shows the sort of the confidence intervals or the standard error around that estimate for that line. And we can turn that off by using this option SE, which is short for standard error. And we just set that to false. And if you're not familiar with these methods, that's okay. The key thing is just to know that this right here gives you the line of best fit, the line that sort of fits through that data the best way. We got about 20 minutes left, and there's quite a few things that I want to get through here. So we'll quickly go through and look at faceting. So this is something we talked about briefly in the first workshop, but it's worth spending a little bit more time on. So you know what I'll do? I'll just copy this here. So we have our standard plot, and we'll leave our line through there. Whoops, through the data. So before, when we looked at the scatter plot, we might want to look at, well, what if we wanted to look at this just for particular continents or each continent individually, right? We could filter the data here and say we only want to look at data that's from North America or Oceania or Asia, or whatever it is. But if we wanted to look at all of those plots, we'd have to do that 5 times, and that's kind of tedious. So what we can do is we can add what's called a facet wrap. And faceting is just making a plot by different subgroups. And to do that, what we'll do is we'll just type this out. And we'll do this, and we'll use this little symbol here called the tilde, which is right above the tab key on your keyboard. And what that's saying is, do this plot here as a function of or by continent. So if we run this here, we will see that we get 5 different plots now, 1 for each continent. And everything we set up in that original plot is done within each of these subplots. So we have the points, we have the lines, and it lets us look at this data within each group, which is really, really helpful, right? If you're working on data, say within province of Manitoba, and you have different data from different cities or different regions, the province, different health areas or whatever it is. Often you want to do things like this, look at plots, but not overall for your entire set of data, irrespective of those different categories, but look at those different categories individually. So this is really, really useful. Now what we'll maybe look at is changing some of these things that we weren't happy with. So let's say that let's stick with this plot here, the scatter plot, and I'm just going to go ahead and add a color for the continent. Maybe I'll just put this on another line so it's still makes it readable. So we've made this plot a number of times now. We got this scatter plot. It's color coded by continent here. But what if, we look at this and there's some things we're not happy with? Like for instance, let's say, we're not happy with these labels here. We want to change these labels. Maybe we don't even want this continent to appear. It's obvious these are continents, and we want to change these to more readable text. We can do that by adding this other function called labs, short for labels, and we can change our X label by saying X, and let's just say we have that say GDP. We run that. Now we see we have GDP. We could change, and I'm just going to put this on another line to make it easy, but we could have life expectancy. Right? And if we wanted to remove this label here that corresponds to color, we can do that by saying we want color to be equal to null. And null is sort of a special word in R that means sort of literally nothing. And if we run that, we'll see that it's removed that label there. And sometimes, you don't necessarily need a label. Like in this instance, it's obvious these are continents, right? It's obvious these aren't countries or anything else. And we can add some additional things here like titles and subtitles and captions and tags, as well as alternative text. And this is text that's sort of embedded within the image for people who are, say, visually impaired. But we could, add something like a caption here. Or let's put we get this little caption down here if we want to label where the data came from or something like that. Another thing that we might want to look at too is moving this legend around, right? So we'll stick with this example here. Maybe I'll just I'll keep these labels up for people who want to look at it. So let's build on this and say, R and ggplot automatically put this label on the right, but what if we need it on the left for some reason? What we're going to do for that is use this function called theme. Oops, theme. And there's an option within there called legend.position. And we can really put about 5 things in here. So we can put right. And if we do that, that's going to put the legend on the right, which is where it started off. We can change that to left. As you might expect, that's going to put it on the left-hand side of the plot. And we can also put it on the top. And you'll notice that sort of nicely gets put horizontal there on the top. And we can also put it on the bottom. So R gives you these options for moving this around, sort of depending on the plot you want to make. Different things are called for. And then in some instances, you might just want to get rid of the legend altogether. In an instance where, we had bar plots and those bars were colored, those bars were already labeled, we didn't really need them. So if you want to get rid of the legend altogether, which you do quite often, you can just put legend position equals none. And when you do that, you just have no legend. So those are different ways of sort of controlling the way that the legend happens. And if you put a comma in tab, you'll see that there's all different sorts of options for, say, the legend. There's legend background and spacing and all these different things. So there's every type of option that you could want for changing not just the legend, but everything else within ggplot. But the nice thing is most of the time you don't have to worry about that because R is going to try to do that for you. R tries to pick some useful defaults for you. So another thing that we looked at that we were kind of unhappy with here is, rather than just have this as 90,000 without any breaks in the number, makes it a little bit hard to read what number this is. You have to sort of visually parse that that's 90,000. And that's not so bad with 90,000, but when you have numbers that are in the billions or the trillions, it makes it very hard to see what those numbers are. So to fix that, what we'll maybe do is just copy this here so we have sort of a bare minimum example to work with. So we have this scatter plot here. And again, these labels aren't so great down here. So to do that, what we can do is change that with this function, really a set of functions that all start with scale and underscore. So, this axis here on the bottom and on the left there are called scales. And if you type in scale x underscore, you'll see that you have all these different options, like, if the data is binned or if it's continuous data like we have where it's a range or dates or date times and that sort of thing. But if we pick this option continuous, one of the things we can change in here are the labels. And so if we could click labels here, what we want to change, and we'll just type this out and then talk about it. We'll type in scales and then two colons, and then comma format. I'll just leave this here, give people a second to type this out. This is, this looks a little different than some of the things we've typed. But what this is saying is this is just a function here. And what I've done here is rather than load in this package scales by typing in library and scales the way we did with some of those other packages, if you're only going to use just one function from a package, you can use this trick here of saying scales and then these two colons just mean that you want to use this function from this package. So it's a nice way of not having to necessarily load in another package when you, in this instance, only want to use one function. It maybe seems a little excessive to load in that whole library just for one function. But what this is going to do is it's going to change our labels to be comma formatted. So every 3 zeros, essentially, it's going to put a comma in there to make it more readable. And if we take a look at our plot here, we see that it's done exactly that, right? So it's changed that so that it's more readable. And again, not so important when you're working with just tens of thousands, but when you're working with, millions or billions, it can be kind of hard to see what it is. And, let's say we also wanted to change this. Well, let's go back to this one plot we made here before. So let's look at, maybe what I'll do is just go back and copy this. Where was it? We're just doing this out of laziness, so we don't have to type this again. So let's say we have this plot here where we had this plot where we had this x-axis filled in as a proportion, right? So it's a proportion now from 0 to 1, which is reasonable enough to understand, but it's nice to maybe put this as a percentage, right? From 0% up to 100% with 25, 50, and 75%. And the nice thing is we can do that really easily by using this idea again here. And in fact, it's so similar, I'm just going to copy and paste this. So we're saying that we have the scale, we want to change something in the scale. That's on the x-axis, not the y-axis. And it's continuous, right? Because we have that continuous range from 0 to 1. If it was a date or something, which we'll look at in a second, we would do something different. But rather than comma format, we're going to change that to percent format. And now when we run that, we're going to see that it's changed our labels. Instead of being from 0 to 1, it's changed it from 0 to 100, and it's put the percent on there, right? Which is kind of nice when you're sharing data with people it's a little bit more clear to think about things in terms of percent often. So that's a really quick way to do that. The last sort of example I'll show you is for working with dates. So let's quickly look back at that economics data, and let's make that quick plot again where we had, I think it was date and what was it? Unemployment. And let's make that line plot. And you'll see that again, R was helpful to us, right? It put these labels here. I put them every 10 years though, right? And that might not be enough, right? We might want these labels a little bit more often. So, and again, I'll just copy this because well, actually, I'll just type it out. So what we can do is, we know we want to change something with the scale, so we'll change scale underscore. It's with the x-axis, not the y-axis, so we'll click that. And then you see we have this one here called x date. So this means every time you see this, that we're changing something on the scale that's on the x-axis, not the y-axis or any other axis, and we're doing something with the date. And if we push tab here, we'll see we get these different options. But the one that concerns us here is date breaks. So if we click that, the nice thing is we can just use sort of regular language to describe how often we want these dates to occur. So right now they're occurring every 10 years, but let's say we want 5 years. We can just literally type in English 5 years. And when we run that, ggplot will figure out what we mean. And you see it's put these dates every 5 years, 1970, 1975, 1980, and so on. Now, one of the things that's changed is it's put these date labels here. But if you look into the help page for this, this function here, it'll show you how to change that. And we don't have time to go into all those details right now, but it'll show you how to change that if you look in here. And it'll give some examples down here for how to change those labels, and if you want things as 1 week and that sort of thing. So if you are someone who uses dates a lot in your plots, this little help page here is really useful. And of course, you can just Google it too to figure that out. So the last thing, probably the couple last things I want to talk about are changing the theme of the plot. So far, every plot we've made has kind of had this gray tiled background. But if we want to change the look of the plot, we can do so with something called a theme. So if we type in theme and then underscore, all these different theme options or these different style options will come up for us. So you see that there's this theme classic. So if I push tab here, what this is going to do is change the overall look of this plot. So if I run this here, it'll change that. You see now it's just a white background, sort of, as the name suggests, the more classic looking plot. But there's also other ones like this theme light that's a little bit more minimal. There's also, to be even more minimal, a theme minimal. And you can just play through these different themes as well as install new themes to get this plot to look just the way that you want. Now we have about 7 minutes left, so there's 2 things that are really important that I want to show. And that's saving plots. The first thing is saving plots. So, you've gone to all this effort to get the plot looking the exact way you want. The question is, well, how do you actually save this so that you can put it in a PowerPoint or email it to someone or just save it on your computer, that sort of thing. And there's 2 main ways to do that. So you see this little window down here, there's this option to export. So if you click that, you can click Save as Image. If you do that, you get an option to save that wherever you want on your computer and give it a name, as well as size and format and all that sort of thing. You can also export it to a PDF or copy it to your clipboard, right? So if you move this the way you want it and get everything just right, you can copy that, and then you have that saved in your clipboard, and so you can paste that in a Word document or an email or whatever it is. That's one way of doing it. The better way to do it, in my opinion, to save these plots is to do so programmatically. So rather than have to click through these menus and save and everything, you can use a function that will save the plot for you and save it to your computer. And this might not seem like a big deal when you're just saving one plot, but when you have, say, a report with 24 plots, you don't want to have to go and save each of those plots automatically. So to do that, you can use this plot or this function called ggsave. And the only thing you really need to give it is a file name in quotes. So if you type in my plot, and I'll just save it as a PNG, standard format. And if you run this plot, run this function, what it's going to do is save the last plot you ran in R to your computer. So you see that it saved the image, it was such and such a size. Now you might wonder where this saved exactly on your computer. And if you go to this Files tab here, you'll see everything in sort of your home directory in R. And we'll talk about how to change these directories and work with these directories in another workshop. But you can see up here where that directory is on your computer. And you see that I have my plot saved as my plot. And if we open this up here, we'll see that sure enough, it's saved. And you can see that it didn't save in exactly the way I wanted it to. So a better thing to do would be to specify some things like the height and the width, the units, and you can even set the dots per inch or the pixels per inch. So, you might want to set the width at 10 and 8 and the units in inches or something like that. And then that'll save according to the resolution and sort of the ratio that you want that image to be. And sometimes it takes a little bit of fiddling around with to get just right. Now, the last quick thing I'll show you is how to take a few different plots and sort of compose them in different ways. So let's make a quick plot here. I use this iris data set, and we'll use this petal length. These are just different variables in the data set. And I'm just going to make a quick scatter plot. And what we'll do is we'll take this whole plot here, which we can just take a look at, and we'll save this to a variable here, just so we have it saved. Now, you could do this multiple times with different types of plots. So let's even just do that quickly. Let's say we'll save this as plot 1, this one is plot 2, and we'll change these variable names. And I'm going a little quick here because we're getting close to the end here. But what I'm doing is saving these 3 different plots. And what we can do is use a package called Patchwork. And so we can load that with library Patchwork. And if you haven't installed this yet, then you'd have to go to the install packages and then type in Patchwork. Now, if you haven't done this yet, you don't have to worry about it at this point, because I'm just going to quickly show you this and then we'll wrap up here. But the nice thing about what this Patchwork package lets you do is it lets you add different plots together. So I have these plots 1, 2, and 3. And if I run this with these pluses here, it will compose them and set them side by side, so you don't have to fiddle around in Paint or Photoshop or move them around in Word or a PowerPoint or something like that. And pluses by default just sort of put them side by side. If we go ahead and we put a slash instead, what that will do is it will actually put that third plot down on its, well, actually, if we do this here, so what we want is these first 2 plots here side by side, and then that slash there will put the third plot below. So you can see that you can compose these plots in these different ways, and you can actually do so in a lot more complicated ways than I'm showing here. If you have 6 different plots or something, you can put them in ways that really let you compose it in a much more structured and sort of complex layout. But we're sort of out of time, and we didn't get to everything that I wanted to talk about. So the last thing I'll just quickly show you, and we'll distribute this to everyone, because we didn't get to everything we wanted to, and people might have missed certain things. We'll send out this little HTML file here, and this has a list of everything we cover, as well as the code for everything we ran today, and more, honestly. So you can go through this and sort of at your leisure, revisit some of these things we talked about. And then at the very end of this document, there's this area here called Plots to Try to Make Yourself. And what I've done is made a dozen or more plots here, and the code is hidden. But what you should try to do is to try to look at this plot and look at the data where it came from, and try to make this plot yourself. Fiddling around for 10 or 15 minutes trying to make some plots that you've never made before. You'll learn more in that 10 minutes, even if you're not successful in making the plots, than you will if you listen to me go on for another hour and a half. You learn so much just by trying and making mistakes and fiddling around. And if you're unsure of where to start, if you click this little code button, it'll drop down the code for you, so you can actually see how to make these plots. But I've hidden that just in case you want to try. And some of the plots, especially the ones towards the end, get fairly complicated and will take some time to figure out how to do. There's this kind of plot here that's kind of cool. They call it a lollipop plot. You can see why. And, you know, it'll really kind of test what you've learned here and some of the other information in this workshop and this document. But thank you very much for joining us. I hope everyone learned a lot about using it. We went into a lot more detail than we did in this sort of first workshop. If you have any questions, that you found this helpful. Thank you very much.
Thank you, Matt. I'm going to stop the recording now.
Sure, thanks.